Hello, Mr. Thompson here with a video math lesson talking about experimental probability. All right, experimental probability. And as we so often do, we're going to start with an example. All right, and in this example, we'll be looking at a situation where there's some basketball going on. All right, and we're going to look at a few players and kind of how they've done. All right, and let's say throughout the season, throughout a regular season, we've kind of calculated how many free throws these three players have taken. Okay, John, Ruth, and Chuck. All right, our imaginary players here. How many free throws they've taken. All right, that's what this is going to be, just how many they've tried and how many baskets they've gotten out of those free throws. Okay, so for example, say John took 46 free throws, Ruth took 27, and Chuck took 52. Okay, and they each made this many baskets. So out of the 46, John made 31. He was successful 31 times. Ruth took 27 and she made 22 of them. Chuck took 52 and made 33. Okay. What we're going to do is we're going to find the experimental probability, okay, for these scenarios. And the way we do that is we just take how many they made, how many were successful over the total attempts. So for John, it's 31 over 46. Okay, and you can plug that into a calculator, or if you can do it in your head, then that's even better. But 31 out of 46 is about 67%. Okay, and different problems may tell you round to this many decimal places or whatever, but we're just going to kind of go with whole percentages. Okay, so 67%. Okay, Ruth got 22 out of 27, which is 81%. Okay, and then finally Chuck got 33 out of 52, so that is 63%. Okay, so that's the experimental probability for John, Ruth, and Chuck. All right, and you could say this is their sort of success rate. This is their free throw shooting percentage, whatever. And looks like Ruth did pretty well. Okay, she didn't have as many. She didn't shoot as many as the other two players, but she made the most percentage-wise. Now, maybe your team is going into the finals, and the coach wants to figure out, okay, if these players take 10 free throws, how many would you expect them to make based on sort of how they did before, okay, based on their experimental probability? What we do is we take, so that's called the expected value. And in this case, it's the expected baskets for 10 free throws, for 10 attempts, right? So what we do is we take the experimental probability, so for John it's 67, and we multiply by the number of trials that we're going to do, so times 10. If he takes 10 free throws, we would expect that he makes about 6.7 baskets, okay? 6.7 he scores on those free throws, okay? 6.7 times. Well, you can't exactly score 6.7 times, so what we can do in this case is round to the nearest, appropriate value. Well, you can only make whole numbers of baskets, so that would round to 7. Okay, because we're talking about, how many times you can shoot a basket. You can't do it part of a time, so it's just going to be 7. That's the nearest whole number. Okay, which is the most appropriate thing for these numbers. Okay, now Ruth had 81% times 10. If you know how this works, 81% is 0.81 times 10. We move the decimal place over, so that'd be 8.1, which of course rounds to 8. Okay, so Ruth would make about 8. Okay, and if Chuck took 10 more shots, he'd probably make 6. Right, 63% of 10 rounds to 6 baskets. Okay, pretty simple, right? That's all there is to it. But let me kind of outline some of this stuff that we've just done. Experimental probability equals the number of occurrences in the experiment over the number of sort of attempts, the number of trials. Okay, so that's sort of the formula for experimental probability. The expected value is the experimental probability times the number of trials that you're going to do. Okay, so this one was kind of in the past, the number of trials you did. This is the number of trials that you might do in the future. Okay, sort of like that. That's why this one is expected. All right, and this one you multiply, this one you divide. Okay, And these things, you can correlate straight to our example. This is the number of baskets that they made throughout the season. All right. This is the number of free throws they took. Okay. This is expected value. This is the number of baskets that they might make in finals. Okay. Experimental probability is simply the number we calculated before, right? These are the same thing. Okay. Number of trials would be the number of free throws that they're going to take in the final game, right? So this writing in blue is just to give you a reference to that previous example, but these are just the formulas, kind of the ways that we calculate those things having to do with experimental probability. All right, that's it for now. Good luck and see you next time.